So here's an interesting challenge to think about. If you had to create this gas stovetop and you needed the ability to change the flame shape based off of this dial, how would you actually simulate that? Because you know that you can't use temperature. Temperature is just buoyancy, right? Buoyancy just has a singular direction, and these flames are going in all directions, so that's not going to work. You also know that the flame field by itself doesn't impact velocity. And so you can't just add more of the flame value to get this effect. So what would you adjust to do this? Well, the answer to that is a field called divergence. And think about it like this. Divergence wants to expand in all directions. So temperature, it's expanding in the direction that buoyancy is. But divergence is expanding in all directions, not just one singular direction like temperature. And so that's really what the main difference is. Within pyro simulations, this is very useful because divergence can explain how gas expands in all directions. As an example, if a bomb went off, then all the areas surrounding that bomb would have a very high divergence. And what would happen in the solver is that the resulting velocity would be the result of the area of high divergence trying to reach zero again. So an area of high divergence wants to be zero, and because of that, you can calculate what velocity things should be when it's moving in all directions. Now, also keep in mind that it's possible to have negative divergence as well. Negative divergence, instead of expanding outwards, goes inwards from all directions. So keep that in mind just as a fun thought. For pyro simulations, you'll almost always have positive divergence values though, because usually heat, flames, explosions, whatever, it's all pressure going outwards rather than inwards. Also keep in mind that you'll hear other terms besides divergence. You'll hear terms like gas or gas released or expansion. All of these terms are referring to a field within DOPS called divergence, and they're all talking about the same sort of thing. So what does this mean in a practical sense for our fire pit simulation? What will this do visually for what we already have? Well, by adding in this divergence, this expansion right here, it's going to cause the flames to puff outwards. So if you ever run into a situation where your flames are looking too stringy, in other words, they're too thin, they don't have very much body towards the base in the middle of the flame, then a great way of bringing those flames outwards is using this expansion in the areas that the flame spawns in. So we have this expansion section right here that's under the flames tab, so that now our flame field is going to be adding divergence to the pyro solver. Now, based on the flame field's value, a different amount of divergence will be added in. So on the left-hand side here, again, we have 0. Flame value 0, that's when the flame reaches the top section, right? And then right where it spawns, that's where the flame value is at its highest. That's going to be about 1. That's the right-hand side of the ramp. So it makes sense for us to add the most divergence right where the flame spawns. And then I'm going to cut off the flame divergence quite a bit as it begins reaching 0. So it's going to start with a lot of pressure going outwards, and then it's going to die off really quickly. And what you'll find is that this will add a nice amount of body towards the center of the center and the lower portions of where the flames spawn. So let's cache this out, see what it does, and then I'll also give you some render comparisons so that you know what the different values might do for you visually. All right, and as you can see, now we end up with something like this. Notice how we are going to cause these flames to go a bit higher up in the air because as divergence adds more velocity, some of that velocity is going in the same direction that our buoyancy, our temperature, is pulling the flame. So because of that, our flames just got taller. Let's go to our adopt net and then go to our flame height and turn that down a little bit as well. So we'll say flame lifespan, and let's set that to perhaps a 1. And then after doing that, let's cache this out and see what that does. All right, there you go. Now we end up with something like this. In the next video, let's move on to density. I'll talk about disturbance, adding that in, how to also cut off density whenever you're working with a sparse pyro solver, and talk a bit about shading when it comes to fire and smoke living right next to each other.